Pretty fun having a working Tesla to play around with. On more than one occasion I would just sit in it and crank the premium audio system up. At some point though I had to bite the bullet and start the disassembly. Really useful having it all together and working, so I was able to do testing and record CAN bus logs of all the different events to help with the reverse engineering. It is quite fun taking things apart. Removing the high voltage battery from an electric vehicle can be a little tricky if you don't have a hoist and some kind of movable platform to place the battery onto. Luckily I already had a hoist, but I would have to make something up to lower the battery onto. I'd previously removed a couple of Nissan Leaf batteries using a pretty janky old dining table that I'd modified. It was sort of dodgy enough using this for the 300 kilos of Nissan Leaf battery, so I wasn't really about to risk putting the Tesla's heavier 400 kilo battery on it. So the solution I came up with was to repurpose a steel bed frame and some old mini quad bike wheels and axles. I feel like it had just the right amount of unjankiness to do the job. All the motors and ancillaries, they're all pretty straightforward job. I also needed to remove the full wiring harness, so I made sure I carefully labelled anything that I had to unplug, just to make things easier down the track. With everything removed from the Tesla, the next thing I did was to reassemble it all back together out of the car. I needed to make sure that I would be able to get it all functioning again before I started removing unwanted items and doing more reverse engineering. I also don't want to have the Land Rover off the road for any longer than necessary, so doing this will make that final installation process much quicker. Here you can see I've basically reassembled the Tesla, or the electronics of the Tesla I guess, without any of the body. You've got a radiator with the automated flaps to adjust the airflow. Got the radar, crash sensors plugged in, the cooling system, the air conditioning. I've got my front drive unit emulators sending the right CAN bus messages, same with the power steering emulators, 12-volt battery, the iBooster, power assisted braking but electric power assisted braking, so that'll be useful in the Land Rover. I've got all the cameras and the autopilot cameras. I've just put some tape over that to protect it a bit, and GPS. Still got the ABS module, basically got it plugged in electronically and then just the ports just linked together or blocked, because I don't actually need it, but I need it, sort of need it there to stop any errors happening. Obviously horns, more cameras. This is a ride height sensors here. This is the main computer basically, the main autopilot and main computer of the car. VC left, sort of the controller, all the things on the left hand side of the vehicle. In that box is all the door stuff, speakers, latches, handles, airbag connectors with a little resistor on them, the main restraints control module, the card reader there. I've just taped my Tesla access card on there, USB ports, the main HVAC distribution unit with the high voltage heater sitting at the bottom there. I would like to incorporate that somehow. That could be a challenge, mainly the connecting the air conditioner unit through the firewall of the Land Rover, and then there's the main air inlet. See if I can work that out. More little speakers that usually sit on top of the dash. This is the VC right, the controller for the right hand side, which has all the plug-in bits for the, the right hand doors and stuff that's on the right hand side of the vehicle. Obviously the main LCD screen, obviously the steering stalks and the column module there with the airbag connectors and switches. Yet to work out how to integrate that. The side autopilot cameras. So the seat belts need to be
connected still, otherwise you'll get an error. I don't have to leave the whole connector in, they just have a little switch in there that I might just leave connected. I've got one set up somewhere like that. So this big unit here is the battery. All the battery modules sit under there. 4 long modules. The Tesla Model 3 has excellent batteries. Problem is they're hard to incorporate into an EV project because they're, well, 1.9 metres long, the long ones in there. There's the penthouse with all the high voltage components under there. This is the main 12 volt outlet from the PCS power control system. Basically charges the 12 volt battery, or really provides power for 12 volt, because you can unplug the 12 volt battery once that's going and it'll run just off that. Big cables for that, so it can do a fair bit of current. Tail lights, rear speakers, rear parking sensors, big subwoofer, so I've got all the audio system, radio, antenna amplifier. There's a Bluetooth module sitting in, is that the Bluetooth module there? Well, I don't need the brakes or calipers or anything, but at the moment I've still got the rear parking brakes plugged in. That will be emulated. Obviously rear motor, that's the motor I'm going to use. The front motor's not there. Bumper module they call this. I think it's designed for the to control a trailer lights, that sort of thing. So here we've got the charging infrastructure that goes into the main battery through the penthouse. So that's the controller for the charger controller there. You got the automated charge flap, the charge port, big cables, really big cables, just for the high voltage, the DC charging, high current charging. And then these smaller ones for the onboard charger. All the cooling's hooked up. There's a lot of cooling pipes and stuff that goes everywhere, including cooling for the main computer. To get that filled properly, you need to provide a vacuum to the coolant glycol. Well, this is the 5-way valve, the super bottle. Obviously, lots of things have to be earthed. This has to be earthed. So I've put cables everywhere to try to earth everything. Usually that would just be earthed through the body or the chassis. I did initially forget to earth this one and got some errors. The biggest problem I've had is the anti-lock braking system, ABS module, which is a generic module really. Like Tesla don't manufacture this. I think it's a Bosch unit or something. That's the thing I've probably had the most trouble emulating. Coming up with different ideas, so I've had to extend these. These are the wheel speed sensors, because I don't have wheel speed sensors in the Land Rover. I'm sort of thinking, if I incorporate them all, this is a hub off the Tesla, quite easily unboltable. Also, the wheel usually bolts on there, but the hub has a little, you can see here, a ring of magnets. You can see I've marked them. And they go past these little Hall effect sensors, which are the wheel speed sensors. When the car's turning, when the motor's turning, it's expecting that the wheels are turning too. So if it doesn't get signals from these, it gets a bit upset and obviously turns off traction control, stability control, and annoyingly regenerative braking, because I don't care about traction control and anti-lock braking stuff, but I do want regenerative braking. So I need to do something here. So this is just a bodge setup. Thinking just incorporating these. This is just a 3D printed holder for these sensors that I'm thinking if I can make a pulley sort of system, maybe belt driven system. This is a BMW belt that just turns with the prop shafts of the Land Rover. That might get around it. I'm having trouble testing that at the moment because as soon as you put it into drive, because there's no wheels and brakes holding these, as soon as you put it into drive or reverse, it puts a bit of power through the motor and it will actually start turning. But you have to put your foot on the brake to turn it on, to put it in drive and park, and then immediately it starts turning it, and it gets a bit upset because it can see you got your foot on the brake, but the wheels are still turning, and the park brake's still in the process of releasing. So anyway, and another thing, obviously, so you got to turn the Tesla on, you got to operate the door handle. It's got to see the door handle being released. So that sort of wakes the car from its sleep. You can see it's on. You can actually hear the pump running at the moment. That will eventually turn off and close the contactors for the main battery and totally go to sleep, although it's always sort of still on, and it comes on every so often to charge the 12-volt battery every so often. But to turn the car on, if you own a Tesla, you know how to do this. You just press the door handle. That wakes the car up, and at the same time triggers the release for the door latch, electronic release, which opens, and the screen will turn on. Then it's expecting you to put weight in the driver's seat. So there's a pressure sensor on the driver's seat. Then it's expecting you obviously to close the door. So that door latch needs to be switched back. And then the screen will stay on with the door closed. If it doesn't see that there's someone in the seat and then you close the door, it'll just turn off again. So, you know, it's got an occupied or non-occupied status. So, but obviously I'm not going to use the handles and the door latches of the Tesla, but they're fairly simple switches, so I've just emulated them, just a basic switch. So I've got one switch here that emulates operating the handle for the Tesla. I can do that now. You can see it's a bit upset because it thinks I've done a manual release, but that's okay. And then another switch just to tell it that, yes, I'm in the seat, there's weight in the seat. And see the door open there, and then I'll switch the switch to turn the door off. See the door close. Last software update didn't work and it's not connecting with Tesla, which I'm fine with, so that's okay. It now thinks I'm sitting in the car, so you know, everything works. I can navigate to places. So I'm trying to emulate it. It's much easier to test it in this state than in the vehicle, so I sort of want to get it running and disconnect door switches and front motors and the rear brakes, but still have it boot up and not complain too much. So then, yeah, if you want to turn the car on, you basically just put your foot on the brake and it boots up. Regenerative braking,'s reduced at the moment. I think that's because it's fairly cool in here. It's not off, but obviously if the battery's cool, it doesn't want to put too much energy into it. So I can put it in reverse or drive, push the brake, and then I'll put it into reverse. Oops, there we go. No, it's in neutral. I didn't put it all the way. There we go. Put it in neutral, and you can see at the back there it's turning. Take my foot off the brake. And it's not coming up with errors. I can use a bit of throttle. You can hear the so now you can hear the anti-lock braking coming on. So yeah, it's not that happy about that at the moment. So yeah, next steps are, yeah, I'll disconnect. I'll get rid of all the it's still got the window winders in there. I'll disconnect all the latches and handles, which I don't need. Take out all the seat belts. Big job is the battery. Taking the PCS all apart and off, taking the modules out and repackaging them so that they'll fit in the rear cargo area of the Land Rover there, which is basically going to mean the two outside modules going on top of the middle modules and packaging it up into another container. I may use actually some of the original battery casing. So it's doing there's still air in the system at the moment that I think it's trying to purge. Sort of a fun sort of thing. So let's basically shut it down by telling it we're getting out of the car, open the door, we're now out of the seat, and close the door.
and then it thinks that we have exited the vehicle.